Okay, welcome back to another math video. In this video, we are going to be doing graphing day one. Um, and this whole unit is going to be focused about kind of sketching graphs of things and finding things about graphs. We're going to kind of expand the type of functions that you know how to graph. And today is going to relate to some stuff we were doing in the last unit as well. But we're kind of going to look at some graphs that you're familiar with. It's just um, we need to kind of look at what the equations for these graphs look like. Um, I know I'm being kind of vague right now, but you'll see in a second kind of the types of graphs that we're dealing with. I just don't want to spoil it, okay? Um, so what we have here is just a right triangle, okay? We did a whole unit on right triangles. You'll notice I have a hypotenuse of this right triangle is 6, and then I'm going to say that this side right here is x, okay? This side here, the vertical side is y. Um, Now basically this right triangle, I have one right triangle right now with a hypotenuse of 6, and then we have a side of x and a side of y on the other sides, right? Um, I want us to kind of look at if we were to take another right triangle with a hypotenuse of 6, kind of the same layout, what that would do and kind of what kind of graph we would get by looking at those. So what we're kind of doing here is if I just change my x and my y here, the hypotenuse is staying the same. That distance is staying 6, okay? But I can kind of change where my x and y are, kind of where that 6 is going, kind of how big this right triangle is, okay? Now, the reason why we kind of want to use this as a right triangle is because we know something about the sides of this right triangle. A right triangle has the Pythagorean theorem true about the sides, right? So we basically know here that a squared plus b squared equals c squared. We would know that x squared plus this y squared would equal 6 squared. And that would happen for um, any point where the hypotenuse is 6, okay? So any point kind of where this length right here is 6 is going to give us something where x squared plus y squared equals 6 squared, okay? And we could even do this triangle like over here. But basically, no matter what x and y are, x squared plus y squared is going to be 6 to have this hypotenuse of 6. Now what I kind of want us to do is look at, as I vary this corner point, right, as I change what x and y are, what is the collection of points that I get out here. So as I kind of vary this point here, what is that tracing out? Well, we can maybe draw in a line to kind of see what's happening. I'm going to start with this point really far down at the bottom over here. I'm going to turn some of these on, okay? And then what I want you to do is kind of look at what graph are you getting as we vary this line right here, okay? So as we vary our point, what are we getting? We are getting a circle, right? Basically because, right, the distance between the origin here, 0, 0, and a point out here is always going to be 6. And so we're just getting kind of a circle here, okay? So basically, in order to find the equation of this circle, okay, we can use kind of this right triangle to help us get the equation of the circle, because we know like this side of the right triangle was x, this side was y. This side was 6, right? And we know the Pythagorean theorem is true for a right triangle. So we would basically know the equation of our circle here, okay? Right now I only have half the circle, but it would continue down on the other side too. The equation of this circle is going to be x squared plus y squared equals 6 squared, okay? That would give us kind of all the points around this circle, okay? So that's kind of what we're going to be looking at today is equations of circles and graphing circles. Last unit we kind of found area of circles and circumference of circles, right? But we didn't usually look at our circles on a coordinate graph. And so that's what we're going to be doing here today is just kind of how do you write the equation of the circle on the graph, and then how do you, if you have a graph of a circle, how do you find the equation of it, okay? So kind of going back and forth between a graph and an equation. What's the connection when it comes to circles, okay? So, sorry. That's what we're going to be doing here. So, I'm going to switch over to another video where I kind of explain how we actually find the equations of circles and how we graph them. And we'll do some examples. But basically, the equation that we're starting out here with is x squared plus y squared equals this 6. This would be the radius squared. So x squared plus y squared equals r squared. Okay, I'll do some more examples here in a sec. So here's a graph of a circle that is in our xy plane, right? This is my x-axis, this is my y-axis, right? And you'll notice here, I have it centered. It's centered at the origin, at 0, 0. This point, the x value is 0, the y value is 0 there, right? So it's centered here. And this one that I've drawn in particular has a radius. Well, the radius is this distance here from the center out to a point on the circle. The radius of this circle is 2, okay? So this is the radius. My radius is 2 for this circle. And I want to try and write an equation for this circle. Okay, so in other words, I want a relationship between x and y, right, that will get all the points on this circle. Okay, so if I take an arbitrary point, I'll say I have some point x and y along the circle, okay? I'm maybe going to move my r so that it's not in the way here. I'll maybe move my 0, 0 too so it's in a better spot. I'll put the 0, 0 right there. That's my origin. And then my radius was 2, okay? Well, if I have some point, x, y, on the circle, okay, so just it has to live on this circle, but I don't know what x and y are. Can we find an equation that relates x and y? Well, x is how far to the left or right you go, right? So it looks like my x is, at least the one I've drawn, is about right there, right? So this right here, this side right here would be x, how far to the left or right you go. And then how far up you go or down, right? This would be y right here. So I've got x is right here, y is right here. Okay? Now, you'll notice between the x and y lines here, there is a right angle. Okay? This angle right here is right, it's 90 degrees, right? Because between horizontal and vertical, that's just 90 degrees. Okay? Well, we've dealt with 90 degrees a lot recently, and mostly in our trigonometry stuff, right? If you have a right triangle, there was some stuff that we could use about triangles. So I kind of want to make a triangle here. I'm going to draw in a third side here, okay? So this side of the triangle is x, this side is y, okay? And I'm just looking for a relationship between x and y. I now have a right triangle here, okay? And we know some relationships about the sides of right triangles. Well, first of all, I know two sides of the triangle. This one's x, this one's y, okay? The third side, this side right here, notice this is the same as you're going from the center of the circle out to a point around the circle, right? You're going from the center outwards to a point on the circle. So this is the radius here, okay? So in my problem, that radius is 2 for this circle, okay? And so now I know I have all three sides of my right triangle, okay? And there's something I know about sides of right triangles. I'll give you a hint. It has a squared and b squared and c squared. It's the Pythagorean theorem. A squared plus b squared is c squared, right? So this side squared plus this side squared is the hypotenuse squared. Okay, so is equal to 2 squared, right? These are my two legs of my right triangle, and then this is my hypotenuse, the long side, right? So, what have I done here? I have been able, any point that I pick around the circle, any xy that I pick, has got to satisfy this equation, right? Because I can draw a right triangle for any point that I pick around this circle, and its sides will have to satisfy the Pythagorean theorem, okay? And so essentially the equation of this circle is x squared plus y squared is 2 squared, which is just 4, okay? So essentially, to get the to get the equation of the circle, we're just using the Pythagorean theorem, okay? Now, you don't necessarily need to know where this equation comes from, but I think it's good to. It kind of helps you it helps you remember it better, where it looks like the Pythagorean theorem, right? A squared plus b squared is c squared. It's x squared plus y squared is, and this is my radius squared, right? So in general, when you have a circle that's centered at 0, 0, we just have our equation is x squared plus y squared is r squared, okay? So that's what will happen as we have circles centered at 0, 0. They'll always have equations like this, okay? So let's look at some examples real quickly, okay? So we just did this one, but let's graph it. Let's kind of start with the equation and graph it. Let's say I have x squared plus y squared is 4. And I want to graph what this looks like, okay? Well, because I have an x squared and a y squared, right, this is a circle. X squared plus y squared gives me a circle equals r squared, right? So in this problem, r squared is 4, right? My general equation is x squared plus y squared is r squared. So these two things have got to be the same. R squared is 4, so then what does R need to be? R would be 2, okay? Just take a square root of both sides, okay? So, what would this look like? I'd be centered at 0, 0, because it's just x squared plus y squared equals r squared. My radius is 2, so from the center, I just go out 2 on each side. Okay? And then I kind of sketch in just a circle. Oh boy. That's a beautiful circle. Sorry, this should actually be a circle, but you get the idea, right? Yeah, that's not circular at all, but you can chuckle at my art skills at home. Okay, so that's our graph of this. X squared plus y squared equals 4. Okay, it's just a circle centered at 0, 0 with a radius of 2. Okay, let's try another example. Scroll a little bit here. Let's try x squared plus y squared is 25. Okay. Well, again, because we have x squared plus y squared, okay, this is going to be a circle. It's going to be centered at 0, 0. But now I just need to find the radius. This part of the equation will give me the radius. That part is r squared is 25. So then what does r need to be? R needs to be 5. Okay? So in other words, I have a radius of 5 of this circle centered at 0, 0. So 1, 2, 3, 4, 5. Just going 5 out on all sides, and then we kind of just sketch in a circle. Again, somewhat misshapen, but not too bad. This part of it actually looks really good. It's just this chunk right there that doesn't look too good. Oh well, I guess I could re-sketch it. Yeah, okay. Anyway, we get the idea. For x squared plus y squared equals a number, this gives us an equation of a circle centered at 0, 0. And the radius you find by taking the square root of the number that's over here on this side. Okay? So let's look at a little bit different of a problem. These were all circles centered at 0, 0, at the origin. Okay? But what if I don't want my circle centered at 0, 0? What can we do in that situation? Okay? And this is where we get to probably the most important idea that we're going to talk about today, our general equation for a circle. This is sometimes called the standard form. Okay? If I want to shift my equation of my circle, I can add something to the x. So if I do x minus h squared, oh, sorry, this should be a y here. Typo, okay. X minus some number squared, y minus some number squared is equal to r squared. Okay, so this is our general equation. H in this equation. This tells me, kind of like in my parabolas, if I had y equals x minus 2 squared plus 3. Do you remember what that did to our parent graph of y equals x squared? This moved me, it does the opposite because it was right next to the x. This moved us right instead of left, right 2, okay? And then this one did exactly what we thought it would do. It moved it up 3, right? So I took my x squared graph, And in that, I would move it right to the right 2 spots and then up 3 spots, okay? Kind of similar thing happening here. This, when I do x minus some number, that's going to move me to the right h, okay? The k in here, this is going to move me, well, it's kind of similar to what we just did. I'm doing y, and I'm shifting it by k, but I'm minusing that k. It is right next to the y, so it will do the opposite of this sign here. It will move me up k. Okay? And then this r squared, r, this is your radius. Okay? So these are the parts of your equation here. Okay? So, if I look at an example here, the equation x minus 2 squared plus, and sorry, this should be a y again, a y plus 1 squared is equal to 49, okay? Well, what does this look like? What can we find out about this equation, okay? This 2 here, minus 2, I just switch the sign on it to get me that I'm moving right 2, because it's next to the x. So I'm going to be moving to the right 2. This plus 1 here with the y, well, if it was a minus 1, I'd move up 1. But it's a plus 1, so I'm actually going to move down 1. I do the opposite of whatever is on the inside with the x and y. Okay, so this tells me I move down 1, and then this is my radius squared, right? R squared is 49 in this equation. So what does r need to be? It will have to be 7, right? I would square root both sides of my equation to get r11, okay? So, what does this mean? It means I took my circle of radius 7, centered at the origin, I moved it to the right 2 and down 1. So the new center, the center of the circle, is going to be to the right 2 and then down 1, so it's going to be minus 1. So you notice I just take these two numbers and switch the signs on them to get my center of my circle. Okay? Let's do another example of this to really solidify this. Okay? So let's look at this x plus 2 squared plus x minus 1 squared is equal to 4. Okay? What will this equation, when I graph it all out, what is that going to look like? Okay? Well, this here tells me I'm going left 2. I switch the sign here so that instead of going right, I'm going left. So I'm going to be left 2. Okay? And again, sorry, there's a bunch of places where x should be y in here. Should always have an x squared and a y squared in your circle equation. Okay? Okay? So this minus 1 here, that is going to move me. Well, I just switch the sign on this. I get a plus 1. So I'm going to go up 1. Okay. Then this 4, what is that? That is the radius squared. Okay? That's the radius squared. So the radius, just to get the radius alone, we're going to square root both sides, and I just get 2. Okay, so essentially what I've done, my center of my circle is left 2. So 1, 2, and then up 1. So right there. Okay, that's my center. Center. Okay. Now, I also know my radius. It is 2. And all the points on the circle are just 2 away from the center. So I will just go 2 out from the center all the way around the circle. And I'll kind of just sketch in what it'll look like. And there is our circle. Okay? So, what did we do? To find the center, I just switch the signs on the things next to the x and y, and those form the point of where the center is. Notice the center is at -2. This is at -2, +1. That's your center, right? And then the radius you can find by square rooting the number that's just by itself on the other side of the equal sign. Okay? So I found my center and I found my radius, and then I just sketch a graph of the circle. Okay? Let's do another. So x squared plus y plus 2 squared is equal to 4. Okay? X squared plus y plus 2 squared is equal to 4. Okay? This is still going to be a circle because we've got x squared and y squared equals a number. Okay? So x squared, y squared is equal to 4, right? What does the 4 mean? Think about it real fast. That is your radius squared. So this tells me that r squared is equal to 4. So then, what does r have to be? We square root 4, and we get 2. Okay, so we know our radius is 2. But what about my center? Well, the center we get by looking at the numbers next to the x and the y. Okay? Now this is a little tricky because there's no number right next to the x in this one, right? On the last one it was like x plus 2 or x minus 2, right? In this one, it's just x squared. So what does that mean about where the center is at? Well, you can think of this as just, since there's nothing here, it would be x plus 0 squared, right? There's nothing there, so it's just plus 0. So the first coordinate of our center will be at 0. The second coordinate, I just take this number and switch the sign. So it's -2. So I'm at, my center is at 0, -2. So 0 is here, and then down 2. So that's my center. Now I know my radius is 2, so I just go 2 out on all sides of my radius. And then we just kind of connect our dots and try and make as good of a circle as we can. Okay? Hopefully that's starting to make a little bit of sense. So essentially the idea is you switch the signs on the numbers next to x and y. Those are the coordinates of your center. And then the thing on the other side, the number, you just square root to get the radius. Okay? One more example that I want to look at before we're done is let's look at this example of x minus 1 squared plus y squared is equal to 7. Okay? And we want to find the center and the radius of this circle. Okay? Well, how do we find the center? We look at the numbers next to the x and y. So I look right here. This is your number next to the x. That's your h in this equation, right? I switch the sign on it. 1, right? And then the number next to y, there isn't a number next to y. So what do we need to put? We need 0. Okay? Because there's nothing there. There's nothing next to the y. So my center is at 1, 0. Just by switching the numbers next to x and y. What will my radius be? Well, what part of the equation tells me the radius? It's this guy right here. Okay? So this tells me r squared equals 7, right? The radius squared equals 7. So what does r need to equal? I would just square root both sides of my equation to get r alone. So we get square root of 7. So my center is at 1, 0, and my radius is the square root of 7, right? Which square root of 7 is a nasty number. It has a big decimal expansion, which is possible to have for these. Generally, I don't think you have to graph them when they have kind of nasty radiuses. But if you ever do have to, you would just throw this in the calculator to get a decimal number and then kind of estimate on your graph. Try and make it look as close as you can to that number. Okay? So hopefully this helps you understand graphing circles. Okay? I just want to, before we're done, I just want to go back and review our general equation before we're done. So our general equation for a circle was x minus h squared and y minus k squared, those added together, is equal to the radius squared, right? And so whatever is next to the h, we take the opposite of that, and that's the center, the x value of the center, and then the whatever number's next to the y, we switch the sign on it, and that's the y coordinate of the center. The radius, we just take the square root of what is on the other side of the equation. Okay, so that's graphing circles. Okay, so you want to go, after finishing this video, go ahead and try the homework problems. And there is a key online that you can check your answers for. Then, once you finish that homework, you won't have to turn that in, but it will help give you some practice with this so you can make sure you have the ideas down. Then, once you finish that homework, go in and take the quiz, and that will go on your grade. Okay? Good luck. Hopefully, circles are starting to make sense. Do some practice with it, and then take the quiz. Thanks, guys. Have a good one.